A satellite with a mass of 300 kilograms moves in a circular orbit 5 times 10 to the 7 meter above the Earth's surface. What is the gravitational force on the satellite? What is the speed of the satellite? What is the period of the satellite? Well, let's take the data. The mass of the satellite is 300 kilograms. The height of the satellite is 5 times 10 to the 7 meter. And the radius of the Earth is the usual value, 6.38 times 10 to the 6 meter. First, what is the gravitational force on the satellite? Gravitational force is G-MEM divided by RE plus H all squared. And all you need to do is put in those values. And GME can be replaced by small g RE squared. And now you have G is 9.8, RE squared, 6.38 times 10 to the 6 E squared, times mass is 300, over RE plus H all squared. And again, put that in the calculator and solve it. Is there anybody who wants me to show you how this is done? Well, let me see if there is one person who wants help with it. Alright, I'm going to hold the calculator here and do that for you and see how it goes. It'll be the numerator, you can type in the way you see it. 9.8 multiplied by, in parentheses, 6.38 times 10 to the power of 6, parenthesis closed, and square it, divided by, parenthesis, the parenthesis, 6.38 times 10 to the power 6 times 10 to the power of 6 plus 5 times 10 to the power of 7, parenthesis closed, and square it. It's a very simple calculation, and that will be 0.12549. Is that right? Well, let's check it one more time. Now, you notice that I did not get the right answer. Now, what was the answer I got? The answer I got was 0.12549, but the actual answer is 37.7. Anybody tell me where did I go wrong? If you watch me do it, I know it. When I was typing the numerator out, I stopped here. I did not multiply by 300. So if you multiply this result 0.12549, which we obtained, by 300, you get 37.7. Okay, well, I made an attempt, and you must be able to put these on your calculator and do your calculations without making a mistake. Well, we did the first part. We found the gravitational force on the satellite. What is the speed of the satellite? How do you find the speed? Now, the gravitational force which we calculated, 37.7 Newton, is a measure of the centripetal force on the satellite, isn't it? Yes, we have used that several times. That means this quantity equal to mv squared over r. So mv squared over re plus h. It is at a height h above the surface, so the distance of the satellite from the center of the Earth is re plus h. mv squared over re plus h is 37.7. Therefore, V equal to, you see, V squared is 37.7 times Re plus H divided by M. Therefore, V equal to square root of 37.7 times Re plus H divided by M. And all these values we know. So place all those values there. 37.7 times Re plus H. H is 5 times 10 to the 7 divided by M. Alright, and that gives me 2,662 meter per second is the speed of the satellite while in orbit. What is the period of the satellite? The time taken for one revolution. Well, once you know the orbital speed, you can find the period very easily. If t is the period of the satellite, then we have t equal to 2 pi r divided by v. Well, this r, the distance of the satellite from the center of the earth, is Re plus h. So the period t equal to 2 pi times Re plus h over v. We know all these quantities. V we just calculated. Radius of the earth we know. H we know. Therefore, use all those values, and that gives you the period is 1.33 times 10 to the power 5 seconds. Well, I think this lesson contained a good number of problems, and you must be familiar with doing all these kinds of problems. Alright? That's about 37 hours. And I'm going to stop this one here. I will get back to you with the last lesson later on.